This is homework assignment from page 96, numbers 3, 4, 5, 7, and 14. Starting with number 3. We are going to be talking about Death Valley, in particular the temperature. We're given lots of data and asked to find the mean, median, and mode. What I'm going to do is come over and go into my stat lists and begin entering in the data. 146 and 180. And again, what I'm going to do is pause for a moment and fill it in. Alright, I finished entering in all the data. Now, of course, the calculator can calculate the mean and the median for you, but for questions in which I'm asking you to show me how you calculate them, I want you to show me the steps. So one thing that I can do is for the mean, we know that the mean is the sum of all the data over the number of data. And so I can go through and I can go into my list and I think over in math we have the sum function. Alright, so we can use the sum of L1 and we have 2,342. And of course, if we go into our stat lists, often what I just do is go to the very bottom and you see the subscript right here tells you how many there are. There are 14. So you're going to have that, which means our mean, let me fill that in. If you do that division, it turns out to be 167.29 degrees as the mean temperature in Death Valley. Now when we talk about the median, we need to have the middle position. Now the median position is going to be n divided by 2, which in this case is going to be 14 divided by 2, which is the 7th position. But as we've talked about before, when you have an even numbered list, there isn't a single middle position. It's a middle pair, so it's going to be the 7th and the 8th position. It's always the result of this and the one above if it's even. If this is an odd numbered list, you'll end up with a 0.5 and then you just round up and you have a single position. So what we're going to have to do is come over here, and this list isn't ordered yet, so we can go to stat and go to our sort A, and we can sort L1 into ascending order. And then when we go in to look at the lists, we can scroll down, and this is the 8th position, 174. Of course, 7th is right before it. So our median is going to be 168 plus 174 divided by 2, which turns out to be 171 degrees. And finally, we need the mode, which, now that we've ordered our list, we can actually just scroll up and visually look for what seems to happen the most frequently. That's 1. There are 2 152s. Looks like there are 2 168s. Looks like there are 3 178s. Yeah, that looks like probably, yep. So it's going to be 178, 178 degrees, which occurred 3 times. In question number 4, we're given information about the size of wolf packs. I've already entered the data into my calculator, so we're simply asked for mean, median, and mode. So we need our sum of values. I can go up, looks like there are 18, so I know n is going to be 18. We can go into math and sum. Oops, oh, I did that from within the list, so that's not good. I have to delete that. So yeah, what I have to do is second quit so I get out of the list. And I'm gonna just go back one. Alright, so the sum is 103, which means our mean I just paused the video there for a moment because this 103 didn't match my notes. And so I went back and I checked the stat list and I was missing a number. I hadn't put it in. So it turns out that this is in fact 111. So let's change that. And the mean is 6.17 wolves. So it might make more sense just to say 6 wolves. I don't know how much we could have 0.17 of a wolf. Median, right, our n over 2, get rid of that, n over 2 is of course 18 over 2, which is going to be 9th and 10th positions. So the median, if we now, we should sort our list. We're going to sort. Now we can go in and we can find our 9th and 10th. Looks like that's 5 and 7. So median will of course be 6. And now for our mode, again we'll look through. Let's start from the top. Looks like we have 3 2s, 3 4s. Oh, we got 4 7s. Oh, looks like 4 7s. So mode is 7, which occurs 4 times. In question number 5, we're given data on the number of injuries that occurred at different landings along the Grand Canyon and the Colorado River. And so they've broken up into 2 regions, the Upper Canyon and the Lower Canyon. And I've already entered in the data. L1 is the Upper Canyon, and I've entered the Lower Canyon into L2. And in Part A, we're simply asked to calculate the mean, median, and mode. So we'll do that quickly. So 36. Maybe I'm going to split this. We'll make this the Upper Canyon, and we'll do the Lower Canyon over here. And we can get the sum. So this is going to be 59. Now we need to get how many data points there are. I can just go to the bottom. Looks like there are 11 in the Upper Canyon. And looks like there's 14 in the Lower Canyon. So for a mean, we get 4.21 injuries in the Lower Canyon, and we get 3.27 injuries in the Upper Canyon. Now if you look at median, there are 11, which is 5.5, so we're looking for the 6th position, and we have oops, I did that, showed that incorrectly, didn't I? Alright, that's supposed to be n over 2. N over 2, which of course is 14 over 2, so we're going to be looking at the 7th and 8th positions. So here the median, let's look at our data. Alright. Oh, I have to sort this, of course. And we sort, let's sort both lists. Alright, now we can go back into our lists. There we go. That's much better. Looking for, there's the 8th. So, of course, the 7th is going to be 2 plus 2 over 2, which is, of course, a median of 2. Over in the Upper Canyon, 6th position, looks like 3. So median is 3. And now let's look for the mode. Oops. We can scroll down, or let's maybe start at the top. 3 1s. Oh, we got 4 3s. Oh, looks like it's 3 then. Alright, which occurred 4 times. Over in the Lower Canyon, start at the top. 2 0s, alright, 3 4 1s. Looks like mode is 1. And that happened 4 times. So this is part A. So we've calculated, the mean, median, and mode for the Upper Canyon, and the mean, median, and mode for the Lower Canyon. At first glance, you can actually see in the Upper Canyon, the mean, median, and mode are all very close to each other. Looks like the Lower Canyon, there's a difference happening here. These aren't too far away from each other. Mean looks like it's quite a bit different. And this is both part A, and Lower Canyon is part B. So part C, we're asked to describe what the distributions are like and what this implies. I'm going to get a new screen here. This is question number 5, letter C. What I'll do is I'm going to pause the video. I'm going to write up a little description, and then we can talk about it. So here I've written out part of my answer for C. For the upper canyon, all measures of center are close to each other, as we said before. This implies a symmetric distribution, so using either 3 or 3.27 as an average would be reasonable and would yield good results if used as a general predictor for all the landings in the future, which of course is what we hope for when we have measures of central tendency, is that they describe fairly well most of the data. And that seems to be the case for the upper canyon. Now, when we look at the lower canyon, it seems to be a little different. And again, I'll pause and write this up. Now, here with the lower canyon, the 3 measures of center are all different, especially the mean. This implies to me a skewed distribution, leading me to believe that a small number of landings are producing more injuries than the majority of landings. This, of course, is very important if I am, the operator of, a tourist company. I need to make sure to identify if there are particular landings that we need to increase our safety measures around. So between these two, right, here we have the upper canyon where the mean and median seem to describe most of the data pretty well. We have the lower canyon where the mean and median are significantly different and neither perhaps are giving us a good picture of what's going on. So the next thing we're asked in part D is to do the 5% trimmed mean for the lower canyon. This might illuminate some of the issues in the lower canyon for us. 5% trimmed means we're going to take 5% off the top and off the bottom of the ordered data list. So first of all, we have to find 5% of 14 data points. So in order to calculate 5%, we figure out that that is 0.7, which of course we would round up to eliminating 1 data point on the top and on the bottom. So here in L2, I'm going to take the 14 and delete it, and then I'm going to go to the top and delete one of the zeros. So now in L2 is the 5% trimmed data list. And of course, we now have not 14 but 12 data points. We can go back and do our sum of L2, and we can get our trimmed mean, sum of the data over the number of data. So that would be 45 over 12. So the mean in that case is 3.75, which, remember, the mean before was 4.21. So that's a fair difference. Now with the median, because it's a symmetric trimming, we've taken off on both ends. So that's not really going to change too much. I mean, our median position, if we go through the exercise, of course, will be 12 over 2, which is the 6th and 7th numbers. And if we look at the 6th and 7th, it's the 2 and 2 again. 2 plus 2 over 2. So the median is still 2. And the mode, of course, before the mode was 1 because it occurred 4 times. We haven't really changed that. So here the mode is still 1, which still occurs 4 times. So in comparison with, let's look back over here, right, our original calculations, right, we had the 4.21, right, median was 2, mode was 2, so those haven't changed at all, which makes sense because with median that's about position, and if we do a symmetric trim, then the middle positions really don't change, right, and we haven't affected the mode at all. Now the mean has dropped. It has, come closer to what the other mean for the upper canyon is. So what that's telling me is that we have some extreme values, which is throwing off the mean, right? Doing that trim definitely affected this mean a fair amount. So that's, again, reinforcing that conclusion that I was writing about here, leading me to believe small number of landings are producing more injuries, small number of extreme values. Right? So as the operator of the Grand Canyon, tour company, I can look at that data and say, all right, I need to identify which of those landings is producing those extreme values and focus on the safety measures around those. Question number 7 is about the salaries of all the employees in the bank. I've already entered all the salaries into L1. Part A, it asks you to calculate the mean of all 12. So we need our sum of the data over the number of data. Clearly there are 12 data points. We can sum of L1, and we have the mean is 346 over 12. So the mean turns out to be 28.83 thousands of dollars, I believe is the units. We should calculate the median. Alright, so we have our midpoint of the list is, of course, the 6th and 7th positions. So we can look, we're going to have to order our list, of course. And now it's ordered. We can go down and look at 6 and 7 is 18 and 19, which means our median would be 18.5 thousands of dollars. And that's part B. And we were asked to compare, and certainly the median is quite a bit different than the mean. The median is significantly lower than the mean. And so the question is asked, which best describes the majority of the employees? Well, I'd have to say the median probably is closer to the majority of the employees than the mean. And what part C asks you to do is omit the president and vice president. So we can go to our data. And of course, there's our vice president. We can get rid of him. And there's our president. We can get rid of her. And now we have omitted our president and vice president. We can recalculate our sum. And that turns out to be 173. And our total is now 10 employees, which means it's, of course, 17.3 for the mean. We can go through the median, and of course, that would be the 5th and 6th positions. which might, because we trimmed off of only one side, these actually might be a little different. So let's look at 5th and 6th is 16 and 18. So the median, of course, would be 17 now. And now there's quite good agreement between the mean and the median. And part D says compare your answers from part C, where we took the president and vice president out, with that part A. Comment on the effect of extreme values on the mean and the median. And as I think we've probably seen in a number of places now, extreme values will affect the mean substantially, but generally doesn't affect the median as much. Primarily because the mean includes the sum of all values. So as soon as you get some extreme values in there, the numerator of this ratio goes up quite a bit. But because the median is about position in the ordered list, then if you have some very extreme values, that actually the value doesn't go into the position. Right? So it's less affected. Now, number 14 is an interesting one. Partly because it doesn't really require any calculation. It's really getting at concepts within statistics. And it talks about, from Thriving on Chaos by Tom Peters, about not using averages. And it says, quote, the use of averages is downright dangerous. He illustrates with examples. Suppose a manufacturing company claims, on average, we ship parts within 37 hours of order entry. But a careful look at data shows that for the worst off 10% of customers, the shipping time was within 89 hours of order entry. Peter's advice is to focus attention on the worst 1, 5, 10, or 25% of customers instead of using the average. And it just asks you to comment on this advice. I'll write up my answer to this in just a moment. So here's my answer to this question. I think it's good advice that he's giving. To use the average means that half of your customers will be unhappy. This is not going to be good for business. 50% of your customers are unhappy. If, on the other hand, you use the worst 10%, then you can think of it as the other side, the 90%. Then 90% of your customers will be satisfied. This will be much better for business. Statistics are great. We need to make sure to use them appropriately, or we might get unanticipated consequences that we don't like.